Good evening, my dear students. Welcome to ACE Engineering College YouTube live session. Myself, Sujath Ali Khan, faculty in physics from ACE Engineering College. So, today, as a part of a series of lectures of applied physics, I would like to explain some important topics, university asked question, more frequently asked question, not only from university, but also from our autonomous syllabus. So as part of that one, I would like to explain chapter 5, means unit 5, which includes lasers and optical fiber. Chapter 5 means unit 5, it is having lasers and optical fiber. In this, I am going to explain what are the contents, means what are the topics that are present in lasers and optical fiber. First one is characteristics of laser. Next quantum states. There are three quantum states are there. What are these quantum states are also very important. Next, we are having Einstein coefficients and their relation. It is the most important question. It is more frequently asked question in the university and as well as in the autonomous syllabus. Okay, Einstein coefficients and what we are having their relationships. Next, what we are having lasing actions. Lasing actions and pumping methods. What is pumping method? What is lasing action? We are going to discuss later. So these are the topics which are present in the lasers and optical. Now, after that, we are having different types of lasers. Ruby laser. What is this? Ruby laser. Next, we are having helium neon laser. Nd:YAG laser. Neodymium, yttrium, okay, aluminum, garnet. So that is Nd:YAG laser. What is this? Nd:YAG laser means Y means yttrium, Y3, okay, Al5, next O12, that is yttrium, agnium laser. So the Nd:YAG laser. Next, we are having semiconductor lasers. These are the different types of lasers. Next, we are having applications of lasers. So whatever the topics that are present here, all these topics are related to lasers only. These are parts of lasers. They are the topics of lasers only. Okay, the first part of the unit 5. So first part of the unit, what it is having? Characteristics of laser. Okay, next what are three quantum processes. Next, what we are having? Einstein coefficient and their relations. Next, lasing actions and pumping methods. Later, we are having different types of lasers. Next, semiconductor laser. So applications of lasers. These are all the part of lasers only. Next, after that, we are having optical fiber as a dielectric waveguide. Next, total internal reflection. What is TIR? TIR is nothing but total internal reflection. So the working principle of optical fiber is nothing but total internal reflection. Next, we are having acceptance angle and numerical aperture. So from optical fiber, this question more repeatedly, so more frequently asked question. You can't imagine a question paper without this question. 90% this question repeats all the time. 90%, you can imagine how important this question is. Okay, acceptance angle, numerical aperture. Next, step index, gradient index. They are the types of optical fiber and losses in optical fiber. What is losses? Means attenuation. Losses means attenuation in optical fiber. Next, optical fiber communication system. So students, listen here. The most important application of optical fiber is in communication. You can't imagine a communication without optical fiber. Okay, so we can't imagine a communication is done without any optical fiber. Nowadays, optical fiber plays a major role in the application of communication. Okay, next, what we are having? Applications of optical fiber. So dear students, all these are contents, means topics which are included in the chapter 5, means unit 5, that is lasers in optical fiber. Okay, so lasers. So what is laser? Laser nothing but simply it is also a light. What is laser? It is also light. but not ordinary light. It is not ordinary light. It is an extraordinary light. Why it is an extraordinary light? It can do some unbelievable things which cannot be done by the ordinary light. Okay, like as reading the information from CD and writing the information into the CD can be done with the help of laser, but we can't do with the help of ordinary light. So that is an extraordinary thing. Drilling and welding of a huge steel blocks can only done with the help of a laser, but we can't do with the ordinary light. Okay, transmission of a data means signals, optical signals can be done a longer distance, okay, with the help of lasers. Okay, lasers can travel a longer distance, some thousands of kilometers also it can travel, whereas ordinary light can't be traveled. So that what we are calling laser is nothing but a light, but not ordinary light. It is a extraordinary light. How it is extraordinary? Because it is amplified. What it is? Amplified. Amplified means strengthened. It is strengthened. Okay, strengthened light means its energy is increased. Okay, how it is increased energy? In the stimulated emission process. In which process the energy of the light is enhanced, means increased. In the stimulated emission process, the energy means the energy of the light is increased, enhanced. Means amplified form of light is called laser. Laser is nothing but light amplification by stimulated emission of radiation. That is a laser. So lasers are classified in different types. Lasers are classified different types depending on the medium. Okay, depending on the medium is used. Okay, so they are, for example, solid state laser. What is that? Solid state laser. You know what is solid? Solid means you know. So solid state lasers are two types. We are having in our here ruby laser. In our syllabus we are having ruby laser. Next ND-AG laser. This is also a solid state laser only. Okay, solid state laser. Next we have gas lasers. What we are having? Gas lasers. Gas lasers, what it includes? Gas laser, the most important one is helium neon laser. What is that? Helium neon laser. CO2 laser means carbon dioxide laser. These are the gases. You know what is helium? It is a gas. What is neon? It is a gas. Means here medium is nothing but gas only. Helium we are using and neon also we are using. These two are gases. With the help of these two gases, we are going to generate lasers. So that laser is said to be as gas laser only. Similarly CO2. CO2 also gas. So by using CO2, we can generate a laser. So that laser is called gas laser. Okay. Next we are having semiconductor laser. Semiconductor lasers. Semiconductor lasers once again classified into two categories, homojunction and heterojunction. What are those? Homojunction and heterojunction. Homojunction and heterojunction. These are the two different types of lasers in semiconductor. So semiconductors lasers are two types, homojunction and heterojunction. Next what we are having, last one is dye laser. DYE, dye laser. It is a liquid laser. Dye laser is a liquid laser. So I am not going to discuss all those things right now. So I am just giving some brief information about the different types of lasers. Different types of lasers. The main topic that I am going to discuss today is this one. This question will fetch you in different way. Differently means not only you are going to get marks directly from this question. If you understand thoroughly this question, you can be able to answer some other questions also. Means learning this single question will make you easier to answer the other questions also. So what are the other questions you can write? You can write from the information of this answer. So these are the questions. Explain the 3 quantum states. Three quantum states, quantum processes. What are three quantum processes? Okay. So also it is also known as interaction of radiation with matter. It is also known as, the question may be asked like this, interaction of radiation. What is radiation here? Light. Light is interacting with matter, means matter is nothing but atom or molecule. So this question, both the same questions only. Okay. So explain the three quantum process, or here what you can write, explain the interaction of radiation with matter. That is, both the questions are same only. So how these questions can answer? From this answer only. If you understand this one, if you know the answer of this one, from this answer only, you can write the answer to this question. Next, what we are having, another thing is, write differences between spontaneous emission and stimulated emission. There are two types of emissions will be there here. You will come to know while we are going on, while we are moving on, you will come to know what is spontaneous emission, what is stimulated emission. Okay. So write the differences between spontaneous emission, stimulated emission. You can write once you know the answer of this one. Okay. So these are the advantage of this question. Okay. So this question is not a single question. It indirectly giving the answers to the other questions also. So it is more frequently asked question. See here, Einstein coefficient and their relations. Okay. Einstein coefficient and relation. This is the question, this is the topic that I am going to discuss today. Okay. So Einstein coefficients and their relation. The three different quantum processes. Before we are going to have a discussion about the Einstein coefficient, we have to know what are the three different quantum processes are there. Okay. So that is the thing that I am going to start with. Okay. Three quantum process. Stimulated absorption. My dear students, listen. Whenever the term comes stimulated means you are using, this is a stimulated. What is it? Stimulated. Whenever the term comes stimulated means we are using some external energy. What you are using? Some external energy. What you are using? Some external energy you are using. You are using some external. So absorption means receiving the energy, means taking that energy. So when energy is given externally, the atoms will excite from lower energy level to higher energy level. So in order to excite the atoms or excite the particles or excite the electrons, what we have to give? We have to give the external energy. What form of energy that we are giving here? We are giving the energy in the form of light, means photon. Photon that we are giving in order to excite the atoms from the lower energy level to higher energy level. So stimulated absorption means, you have to remember once again, whenever the term stimulated comes means you are using some external energy, means photon energy. So that energy is given to the atoms present in the ground state. Okay. What happened when atoms are present in the ground state? See here, it is the lowest energy level or ground state. What is this? It is a ground state. Ground state means lower energy, even. So usually atoms are present, it is a higher energy level or upper energy level. That is upper energy level or higher energy level. So here you have to remember always, you have to write that E2 is always greater than E1. Here in this case, E2 is the upper level, E1 is the lower level. For example, if it is having 0.2 electron volt, here you are having 1.4 electron volt, there is a difference between the two energy levels. So E2 is the upper, means E2 is greater than E1. So here see, what you are having here, atoms. Atoms are present in the ground state. Why atoms are present in the ground state? Obviously, for example, everybody wants to get the stability. Everybody want to get the stability. For example, students, once you enter into the classroom, you will like to find the place where you feel comfortable. I repeat, once you enters into the classroom, you check which place is suitable to you, where you feel comfortable. Means you want to get stability. Similarly, atoms also want to get stability. Where they find the more stability? They find more stability in the ground state. So that is a lower energy level. Now what I am doing, see here, these are the photons of sufficient energy. This photon energy, this photon having certain energy, na? How much of energy this photon should have? So whatever the gap, for example, here 1.2, here 2. So the difference is, here what we are having 1.2 electron volts. Here you are having 2.2 electron volts. Okay, two different energies that we are having, lower energy and upper energy. What is the difference between them? The difference is 1 electron volt. So the photon that is falling on the atom should have this much of energy. Then what happened to this photon? This photon, see what happened? This is E1 and E2. So E2 is always greater than, what you have to write? E2 is always greater than E1. E2 is always greater than E1. So that you have to remember all the time. Okay, so this is E2. You have to remember that E2 is always greater than E1. Now it is a lower energy level and it is a higher energy level. What happened? See here, the atoms are excited from this level to this level, E1 level to E2 level. So what you are finding here in E2 level, see atoms with absorbed photon. Atoms with absorbed photon. Here the photons are absorbed. So that is absorption. Which absorption it is? External energy absorption, means stimulated absorption. I repeat the statement, definition of the this one. The excitation of atoms from the lower energy level to higher energy level, lower energy level to higher energy level, by absorbing the photon of sufficient energy is called stimulated absorption. I repeat, excitation of atoms from lower energy level to higher energy level by absorbing external photon energy is called stimulated absorption. See here. See. So stimulated absorption occurs when a photon strikes. What is that? Photon. What is that? Photon. Photon is nothing but light. Okay, light, a packet of energy. Okay, photon is nothing but packet of energy. Okay, a photon strikes an atom. What it is striking? This is an atom. It is a photon. A photon is striking the atom. Okay, what happened? Which is present in the ground state. Where the atom is present? In the ground state. With just exactly the same as an induced an electronic transition. The same energy induce an electronic transition between the two energy states. So electronic transition. For example, this is one electronic level and it is one electronic level. This is the electron transition takes place this one level to another level. How the electrons are transition takes place from one energy level to another level, like that atoms also transition takes place from lower energy level to higher energy level. So come to here, I am explaining 3 quantum processes. In that, first one is stimulated absorption. Stimulated terms comes now, means external energy we are using. Which energy? Photon energy we are using. To whom we are using? To the atoms present in the ground state. When we are providing some external energy to these atoms which are present in the ground state, what happened? They will absorb this energy and excite it to the higher energy level. So they are absorbing and external energy. So that is called the absorption of external energy by the atoms and exciting from lower energy level to higher energy level is called stimulated absorption. Next, another quantum process. There are 3 quantum processes are there. First one is stimulated absorption. Second one is, once the absorption takes place, what happened? For example, this pen, you can see, once we are giving certain amount of energy, what happened to the pen? It is excited to some level. But this pen is going to stay in that particular level? No. The pen once again coming down to the lower energy level. Okay, the pen won't stay into the higher energy level, excited level. It will once again come down to the lower energy level. So when similarly here also the atom absorb the external photon energy and excited to the higher energy level. So that atom won't stay in the higher energy level for a longer time. Its lifetime is very less. Lifetime, what is lifetime? What is lifetime? The amount of time. What is it? the amount of time that atom spends in the excited level. Excited level. The atom is exciting from lower energy level to higher energy. The amount of time, lifetime is nothing but the amount of time that atoms spends in the excited level. Atom spends in the excited level. How much time the atom spends? The amount of time that atom spends in the higher energy level, it will have more lifetime. But the lifetime of the excited atom is very less. How much it is? 10 to the power of minus 8 second. 10 to the power of minus 8 second. Very less. So one picture lo cheptu meruputiga okasari vachipomma antam kada. So like that, so you can't see that meruputiga. Similarly, here the transition of atom from higher energy level to lower energy level, we can't see. How much faster it is reaches to the excited level, that same pace it will come down to the ground state. Okay, so the lifetime is very less, 10 to the power of minus 8 second. Okay, now come to here. Okay, second quantum process, spontaneous emission. First one is stimulated absorption is over. Next, spontaneous emission. What is spontaneous emission? See here. So we know that these are the two energy states, energy levels, E1 and E2. So by seeing the diagram, one can easily say that E2 is the upper energy level, E1 is the lower energy level. Okay. So from this, what we can say that E2 is greater than E1. E2 is greater than E1. Okay. Now, so in the emission, when emission takes place, when the transition takes place from the higher energy level to lower energy level, then emission of the photon will take place. Absorption, when it takes place, when atoms are moving from lower to higher, they will absorb the energy. But emission takes place when the transition of atom takes place from the higher energy level to lower energy level, they will emit the energy. So that called emission of energy. So here two types of emissions are there. In the two types of emission, I am discussing about spontaneous emission. See here, it is a lower energy level and it is a higher energy level. E2 is greater than E1. Now, atoms are present in the higher energy level. So what they are having, see here, what they are having photons in it. They are having photons in it. Okay, the atoms are having photons. Okay, absorbed photon. Now, what happened to these atoms? Now, see this, the transition of these atoms from this level to this level. What happened? You can see there. So, see, atoms are coming down. So what you are observing, is there any photon is present here? Like during the absorption, there is a photon is present in the atom. But when atom come down to the ground state, there is no photon present in the atom. Where that photon gone? See here, it is emitted. The atoms emitted that photon, what they absorbed during the upward transition, means during the absorption, stimulated absorption. So the photons emitted from the atom when they are coming from higher energy level to lower energy level, they are emitting the photons. So emission of photon by the atoms when they are coming from higher energy level to lower energy level by themselves. Okay, what here? Here we are not applying any external energy to the atoms to come down here. Are you applying any energy here to the atoms? No. Here you are not applying any energy to the atom. By themselves they are coming down. So by themselves they are coming down and releasing the photon. How the photons are? See, by seeing these photon direction, they are not in phase. They are not having any directionality. Okay, so when they are not in phase, their energy will be less. Means they are ordinary light. Their frequency will be of different. When the transition of atoms takes place from higher energy level to lower energy level, they will emit the photon in random direction. The emitted photon will not maintain uniformity. They will not maintain a constant phase. They will not maintain one particular direction. So when they are not maintaining uniformity, their frequency will be of different. Means when the frequency of light is different, means you are getting different color light. Different color light is nothing but ordinary light. So from this, what you understood? In spontaneous emission, the photon emitted by the atom produce which kind of light? Ordinary light. Ordinary light emission takes place. Okay, so the direction is random direction. They are not in one particular direction. That is spontaneous emission. So there are one more emission is there. Means third quantum process. Okay, see here. This is spontaneous emission. The excited atom present in the higher energy level. What is the higher energy level? E2 will come down. The atom is come down from where? From level E2 to where it is coming? Ground state. What is the ground state here? It is a ground state is nothing but E1. So atom is coming from where? E2 to E1. So spontaneously it is coming spontaneously and by themselves. Atoms are coming down higher energy level to lower energy level by themselves spontaneously. So by emitting, what they are emitting, see here, these atoms are emitting photon. These atoms are emitting photon. Is called spontaneous emission. That is called spontaneous emission. This is a second quantum process. What it is? It is a second quantum process. What is the first quantum process, my dear students? Stimulated absorption. Stimulated absorption. The second one is spontaneous. Once absorption takes place, the atoms won't stay. When atom transition takes place from lower energy level E1 to higher energy level E2, okay, these atoms won't stay here for permanently. They will come down. They are coming down to the ground state and releases the energy in the form of photon. That will be two types: spontaneous emission, stimulated. Just now we discussed spontaneous emission. We are having one more kind of emission, stimulated emission. As I told you earlier, what I told you, my dear students, what you are seeing here, see the diagram, see the statement here, stimulated emission. What you understood? Once again, the term stimulated is repeated here. What is there? Stimulated. Stimulated term means you are using some external energy. Emission means what? Atoms are coming from higher energy level to lower energy level and releasing the energy. Emission always takes from, when it is emission takes place, when atom transition takes place from higher to lower energy level. Okay. Here, how they are transmitting, how the atoms are coming down? By external photon energy, some external energy. Okay, see here. So E1 and E2, which is higher energy level? Very good, E2. Which is lower energy level? E1. So E2 is always greater than E2. Now, what you are having, see the atoms, where the atoms are present in the higher energy level. What you are finding here, see here, what are these? These are the absorbed photon during the stimulated absorption. During the stimulated absorption, they absorb the photon. So the photons are present in the atom, in the excited level. Now, earlier in spontaneous emission, atoms spontaneously coming from E2 level to E1 level. But in the case of stimulated emission, what happened? They won't come to ground state by themselves. They are, see here, how they are coming. See, what you are doing? You are giving some external photons to these atoms. What you are doing? You are giving some external photons to these atoms. Now, what happened to these atoms? These atoms will come down. So, when the atoms are coming down, what happens here? So, two types, how many photons that you are going to get? One is emitted photon, another one is interacted photon. What is interacted photon? These photons, see here, this photon and this photon. These two photons are called interacting photons. Next, emitted photons means whatever the photons absorbed during the excitation, means in the stimulated absorption process. So these photons will emitted. So those photons means absorbed photon. These are called emitted photon. What are these? Emitted photons. So these are interacting photons. What are these? Interacting photons. Now we are having two photons. One is absorbed photon, okay, that photons will emitted. So emitted photon. Now see what happened, these photons. So the four atoms are coming down. Is any photon present? No photon present in the atom. So where the photons went? See here. So these photons By seeing the diagram, one can easily understood that the emitted photon. For example, this is one interacting photon. Okay, na? It is emitted photon of one atom. It is an interacting photon of one atom. It is emitted photon. Similarly, it is an interacting photon and it is emitted photon. How these photons in the stimulated emission, the photons are maintaining a constant phase difference or a phase difference 0. Constant phase difference or phase difference 0. Then the waves are said to be coherent waves. Coherent form of light emission. What? Which form of light? Coherence light. Coherent form of light emission. Coherent form of light emission. Light emitted. Okay, it's coherent. When a light is having coherent, obviously it will have directionality and also having constant frequency, same frequency. When it is having same frequency, then the light will produce a single color. When there is no change in the frequency of light, remember, when there is no change in the frequency of light, then the light will give only one color, single color, means monochromatic. Okay, monochromatic. When the light rays are traveling uniformly, see here, it is one wave, it is one more wave. How the waves are traveling? With constant phase difference. Then the power of the light will enhanced, amplified. The power of the light will be amplified. So compared to, see here, one light is moving like this, one light is moving in the other direction. So they are not maintaining constant phase difference. They are not maintaining directionality. Then the energy of these photons will be decreased, diminished. Where in the case of stimulated emission, whatever the photons are emitted, they are maintaining a constant phase difference, okay, and particular directionality. So they will give a single color, means monochromatic, whereas ordinary light will have different frequencies. That is called polychromatic. Where you are getting ordinary light emission? In the second quantum process, spontaneous emission. Atoms are coming from higher energy level to lower energy level spontaneously and releasing the photon. How the photons were? They are in random direction, not in one particular direction. So when the photons are in different direction, their frequency will be different. When frequency is different, their colors also different. Means different color means polychromatic. So ordinarily in spontaneous emission, what you are getting? Polychromatic light. Stimulated emission, what you are getting? See here. Laser. What you are getting? Laser. So the definition itself is saying, what is the abbreviation of laser? Light amplification. Light is amplified, means strengthened, it becomes strengthened. How? Light amplification by stimulated emission of radiation. In which emission? Two types of emissions we are having. Spontaneous emission and stimulated emission. In which emission you are having? Laser light? Stimulated emission. So the stimulated emission is the most important concept that is needed to understand the laser action. Okay, stimulated emission. See here, the transition of atoms. What? Transition of atom from where? Higher energy state, means E2. What is the higher energy state? This is the higher energy state. So to lower energy state. What is the another state? Lower energy state. It is a lower energy state. So atoms transition takes place from this level to lower energy level. So what happened to the photons? By themselves they are coming? The atoms are coming by themselves from higher energy level to lower energy level? No. So what happened? So spontaneously emitted photon is known as stimulated emission. Means here atoms are coming from higher energy level to lower energy level by themselves. It is not like that. Who is causing the transition of atom from higher energy level to lower energy level? So remember, my dear students, see here, I will explain. See here. Here is the higher energy level E2. What is this? E2. Here it is what? E1. So what I know? What you know? E2 is greater than E1. Okay. So atoms are present here. See here, this is one atom having some photons in it. It is one more atom having photon in it. It is one more atom having photon in it. It is one more atom having photon in it. Like the different atoms are there, okay, having photon in it. For example, this atom come down to the ground state. This atom come down to the ground state. So what happened? It releases the photon. Okay. So I will write one more time. This is atom. It is atom. It is also atom. Okay. So the atoms already having absorbed photons. What they are having? Absorbed photons in them. So one of the atom come down to the ground state by itself, means spontaneously coming down. The atom is coming down spontaneously. When it is coming down, what happened? It releases the photon. What it do? It releases the photon. Okay. So spontaneous photon. This photon will experience reflections from the mirrors. Okay. Now these photons get back and interacted with these atoms. Okay. So spontaneously emitted photons are interacting with the atoms present in the higher energy level and causing the transition of atoms from higher energy level to lower energy level. So that means now how many photons that you are going to get? 2 photons. These are the 2 photons. Now these 2 photons, once again, these 2 photons are in coherence. They are in one particular direction. These 2 photons once again going to have experience of collision, means interact. These 2 photons once again interact with the 2 more atoms, present in the excited level. So one more thing you have to remember, one atom can only interact with, one photon can interact with one atom only. Though the photon of higher energy can't excite more number of atoms from the lower energy level to higher energy level. Though the incident photon, interacting photon having much higher energy, it can't excite more number of atoms. Okay, it can only excite, or it can only transit from higher energy level to lower energy level or to one atom only. Okay, so these are, see here. So the transition of atoms from where? Higher energy state E1 to lower energy state E1, higher energy state E2. What is the higher energy state? E2. What is the lower energy state? E1. With some external energy. How this external energy you got? You are whatever the spontaneous sum of the atoms present in the higher energy level come down spontaneously. These 4 atoms will release some energy. So these photon will interacting externally and causing the transition of atoms to the downward direction. And these photons will have a constant phase difference. They are having a particular directionality. So the light which is having coherent form and maintaining directionality, so those lights are called laser lights. So finally, in which emission you are getting laser? Spontaneous or stimulated? Not spontaneous. The emission of laser takes place in the stimulated emission, means third quantum process. So this is about 3 different quantum process. Now I am going to explain about I am going to derive the relation, Einstein coefficient and their relations. Einstein coefficient and their relation. So for that, how many transitions are there? Stimulated absorption. Now coming down, spontaneous emission. Another one is stimulated emission. Okay, so we are having 3 types. First I am going to explain about stimulated absorption rate. The rate of stimulated, whenever the term rate means you have to explain with respect to time. What is it? With respect to time. It is related to time. So stimulated absorption rate. Absorption means receiving the information, absorbing the energy. Stimulated absorption means external photon is absorbed by the atom. So that is rate, means with respect to time. So how it depends? See here, we are having, It is the higher energy level, upper energy level. It is a lower energy level. So these are the two energy levels. Now see here, this is atom. These are the atoms present. Okay, the transition of atoms from lower energy level to higher energy. Why? Because it is stimulated absorption. What it is? Stimulated. Absorption means whenever the energy is absorbed, these atoms will be excited from lower energy level to higher energy level. So the stimulated absorption rate depends on the number of atoms present in the lower energy level. So that is nothing but N1. That is nothing but N1. If you are having more number of atoms, then only it is possible to transmit the atoms more number. If you are having less number of atoms in the ground state, you can't have a transition of more atoms. So the transition rate will depends on the number of atoms. For example, if you are having a class, you are in a class. So the number of persons, the number of students are leaving from the gate, leaving from the door. It depends on the number of people present in the classroom. If you are not having more number of students in the classroom, so you can't imagine that more number of students can leave the class. Okay, so that means similarly here also, so E1 is the lower energy level, E2 is the higher energy level. So here in lower energy level, atoms are present. So these are the atoms. How many number of atoms are present? N1. So it depends on number of atoms present in the lower energy level. Similarly, the number of photons are interacting with the atom. The number of photons interacting with the atom. For example, you have, here 4 atoms. But how many photons do you have sufficient energy? Only 3 atoms. So there is a possibility of transition of 4 atoms from lower energy level to higher energy level. But what you lack of? The required number of photons. As I told you, one photon can excite one atom only. One photon can excite one atom only. So how many photons that we are having here? 3 photons. So how many atoms will excite here? 3 atoms only. Means, so transition rate, stimulated absorption rate not only depends on the number of atom N2, it also depends on the number of photons. Number of photons, that is called photon density. What it is called? Photon density. Photon density is denoted with letter rho nu. Okay, so we'll come to know. See here. I'm going to write R. R is the rate. Which kind of rate it is? Stimulated absorption. What it is? Stimulated absorption rate. It is directly proportional to number of atoms present in the ground state. How many number of atoms are there? N1. And also present photon density. As I told you, whenever the term stimulated come across, means you have to apply some amount of photons. The number of photons per unit volume is nothing but photon density. So it depends on photon density. Okay, and the transition time, it also depends on transition time. How much time that takes place, transition of atoms from the lower energy level to higher energy level. Say for example, delta T is the transition time. So delta T, it also depends on delta T. Delta T. So here what is N1? Number of atoms present in the ground state. What is rho nu? Photon density. What is delta T? Transition time. Okay. When you are removing the proportionality, what you are getting here? A constant that is called B12 and N1 rho nu and delta T. So where let it be equation 1. What is B12 here? What is B12? Einstein coefficient. What is this? Einstein coefficient that we are discussing. Einstein relation between, what is this? Einstein coefficient. Now we got one Einstein coefficient. What is B12? Einstein coefficient for stimulated absorption. For what? Stimulated, which kind of absorption it is? Stimulated absorption. So this is equation 1. So you have to remember what is the stimulated absorption rate equation that we got? B12 N1 rho nu and delta T. What is B12? That is a proportionality constant. So what I named it, that one? It is a Einstein coefficient for stimulated absorption. Then afterwards what I am having? N1. What is N1? Number of atoms present in the ground state. What is rho nu? Number of photons interacted with the atoms present in the ground state. That is called photon density. Next, what is delta T? Transition time. For example, transition time is 2 seconds, 1 second, like this. You have to maintain that one. So that is a delta T. So that is the equation for stimulated absorption rate. Next, once absorption is over, the transition come down. So downward transition. Okay, that means atoms should come from higher energy level to lower energy level. When they are coming, the atoms will come two different ways. Sometimes the atoms come down by themselves, means spontaneously. Sometimes the external photons are used to de-excite the atom from higher energy level to lower energy level. So emission will be two types: spontaneous emission, stimulated emission. First one is stimulated absorption. Next one, spontaneous emission. Spontaneous emission, atoms coming from higher energy states to lower energy state by themselves spontaneously. See here, I am going to draw. So see here, it is E2 level. What is that? E2 level. Next, what I am having? E1 level. E2 level and E1 level that I am having. Okay, E2 is the excited level. E1 is the lowest energy level, lower energy level. So atoms are present here. What are these? Atoms are present in the excited level. Atoms are present. Okay. Now the number of atoms present here is N2. In E2 level, how many number of atoms are present? N2. So simple spontaneous emission just depends on number of atoms present in the N2. Why it is only depends on number of atoms? Why not photon density like as stimulated absorption? Because we are not giving any external photon energy to the atoms present in the excited level to come down to the ground state. The atoms are coming down by themselves spontaneously. So no question of external photon density. Only it depends on number of atoms. It depends on only number of atoms. So next what I am writing here? R. What is R here? Transition rate. Which kind of transition? Spontaneous emission rate. Okay, now downward transition. So that is what? Spontaneous emission. Spontaneous emission rate directly proportional to what? Number of atoms present in the excited level. How many number of atoms are present in the excited level? N2. And also transition time. We are using same amount of transition time, delta T. So upward transition time also same and the downward transition time also same. What is the time? Delta T. When you are removing the proportionality, we will get a constant. What is that constant? A21 N2 and delta T. A21 into delta T. So this is spontaneous emission transition rate. What is this? Spontaneous emission rate. So it is equation 2. Now we completed two things. One is stimulated absorption rate. Second one is spontaneous emission rate. Next, third one is stimulated emission rate. Stimulated emission, as I told you earlier. So for example, we have two energy levels. What is this? E2. Next, this is E1. Now atoms are present here. where the atoms are present in the excited level. So the number of atoms present in the excited level is N2. Stimulated means immediately you have to recall that I said whenever the term stimulated means external photons are used, means external photon density is used, means external photons are used. So this means external photons. These are the external photons. These are the external photons. For example, see here, you have N2 number of atoms. For example, this many number of atoms, 1, 2, 3, 3, 6, 6 atoms are there. But how many external photons are interacting? Only 4. Means it not only depends on the number of atoms present in the E2 level, means the transition of atoms from E2 level to E1 level. So it not only depends on the number of atoms here, N2, but also depends on the number of photons interacted with the atoms present in the E2 level. So that means transition rate. Which transition rate? Stimulated emission rate depends on the number of atoms, that is one thing, and the number of atoms, that is one thing. Second one is the number of photons, means photon density, which are interacting with the atoms present in the excited level. So what is the transition time? Same delta T. So what I am going to write here, see here, what I am writing here, what is our transition rate? Which kind of transition rate? Stimulated. What is this? Stimulated emission. So stimulated emission rate directly proportional to, stimulated emission rate is directly proportional to number of atoms present in the level N2, and also photon density, that is rho nu, okay, and also the transition time delta T. N2 is nothing but number of atoms in the E2 level. Why E2 level? Because atoms are coming from higher energy level to lower energy level, means you have to write N2. What is rho nu? Photon density, means number of photons which are interacted with the atoms in the higher. What is delta T? Transition time. We have to maintain at same time transition time for stimulated absorption, spontaneous emission, and stimulated emission. So once we remove the proportionality, what I am getting here? One constant, that is B21, that is a proportionality constant, N2, rho nu, and delta T. See here, what I am getting earlier case, this is a spontaneous emission rate. Now what is this? Stimulated emission rate. What is this one? First one, stimulated absorption rate. What you are having? One Einstein coefficient, B12. Second one, we are having one more Einstein coefficient. What is A21? A21 is the Einstein coefficient. What is this? Einstein coefficient for spontaneous emission. What is spontaneous emission? So see here, we got B12, that is Einstein coefficient for stimulated absorption. Next we are having A21, that is a spontaneous emission coefficient. Now last one we have B21. It is also what? It is equation 3. What is B21? B21. What is B21? It is a Einstein coefficient. What is this? Einstein coefficient for stimulated emission. What is this? Stimulated emission. Einstein coefficient for stimulated emission. Now we are ready with 3 Einstein coefficient. One is for stimulated absorption, one is for spontaneous emission, one is for stimulated emission. Now, at equilibrium, what is equilibrium here? Upward transition is equal to downward transition. The number of atoms are excited from lower energy level to higher energy level. That is nothing but, see here, equilibrium means the excitation of atoms from lower energy level to higher energy level. that is upward transition. That is called upward transition. Okay, so this upward transition is equal to what? See here, how many number of atoms are come down to the ground state? Same number of atoms. That is called downward transition. Downward transition. So both are same. Upward transition is equal to downward transition. That is called at equilibrium condition, at equilibrium state. At equilibrium what is equilibrium? Upward transition is equal to downward transition. What is that? Upward transition is equal to downward transition. Okay. What is upward transition? Only one upward transition is there. What is that? Stimulated absorption. What is this? Stimulated absorption. What is the downward transition? Two things that we are having. Spontaneous emission plus one more emission. What is that one more emission? We are having only one emission. Emission obviously takes place when the transition of atom takes place from higher energy level to lower energy level. So two types of emission that we are having. Spontaneous emission and also stimulated emission. Second one is stimulated emission. Stimulated emission rate. Emission rate. Spontaneous emission rate, stimulated emission rate, stimulated absorption rate. Just now we derive stimulated absorption rate. Just now we derive. What is that? B12 N1 rho nu and transition time is delta T. That is equal to, what is B12? Transition, Einstein coefficient. So one more thing, people might have some doubt. Sir, B12 is Einstein coefficient, we understood. And that to be stimulated absorption coefficient. Sir, what about the 12? Why you wrote 12? See here. Here I wrote 21. Here I wrote 21. See here, what I wrote here? B12. I wrote B12, I wrote B21, A21 and B21. So there is a difference here. So we know that B12, A21 and B21, they are the Einstein coefficient. Why we are having 1, 2 and 2, 1? 1, 2 is nothing but the transition is taking place from E1 level to E2 level. So that is, sorry, what is the transition? This is E1 and it is E2. Okay, the transition is taking place from E1 to E2, means upward transition, means stimulated absorption. So in that stimulated absorption, what I wrote? Transition is taking place from 1 to 2. Next, emission means what happened? Atoms are coming from higher energy level, E2. What is this? E2 to E1. Atom is coming from 2 level to second level to first level, means higher energy level to second level. So that is 2-1. Why, sir, why we are not using here B21? You people have some doubt. So because it is not related to stimulated. It is of spontaneous. For that I am using A21. See here in stimulated I use B21. So okay na? So this is the B12 is equal to B12. This is stimulated absorption rate. Next, what is spontaneous emission rate? This one. What is this? Spontaneous emission rate. So what I am writing here? A21, number of atoms N2, and transition time delta T. It is a spontaneous emission rate. Next, second, plus stimulated emission rate. What is stimulated emission rate? See here, B12 N2 rho nu. So that is stimulated emission rate. B12 rho nu and N2 transition time delta T. Okay, see here, who is common here? So delta T, here also delta T, here also delta T. So I am removing the delta T. So what you are left out here? B12 N1 rho nu is equal to A21 N2 plus B12 rho nu N2. So see here you are having rho nu, photon density. Here also you are having photon density, rho nu. So rho nu you are having. So what I am doing, I am writing these terms at one side. Means B12 N1 rho nu, this rho nu term minus this is B21. What it is? It is B21. Okay, B21 into rho nu into is equal to what you are having? A21 N2. A21 N2. A21 N2. Okay, so you have to take common. See here, I am going to next slide here. Rho nu I am taking common here. Rho nu here, rho nu here. So what you are going to have? See, rho nu is common here. When you take rho nu common, what you are having? B12 N1. What you are having? B12 N1 minus similarly a rho nu common B21 N2. What you are having? B21 N2. That is equal to. So what you are having right side? A21 N2. What you are having? A21 N2. So that is a A21 N2. So from this rho nu, what you can write here? Rho nu is equal to A21 N2 by B12 N1 minus B21 N2. So let it be equation 4. Let it be equation 4. What are the first three equations? One is for stimulated absorption rate. Second one is spontaneous emission rate. Third one is stimulated emission rate. Three equations are. Now this is the fourth equation. Now from this equation, this term B21 by N2 is there. No? I am dividing this equation with this B21 N2. See here what I am doing. When I divided here A21 N2, to whom with I am dividing with this circle one. So B21 N2 by what you are having? B12 and N1. So dividing with B21 N2. So B21 N2 by B21 N2 means what you are getting? 1 only. You are getting 1. So here who is cancel? N2, N2 cancel. N2, N2 cancel. Next what you are having, what you left out here? Rho nu is equal to A21 by B21. What you left out here? Here A21, here you left out with B21. That only now in the numerator. Next here what you are having? N1 by N2 I am writing first. What I am writing here? N1 by N2 into what you are having? B12. B12 by B21 minus So that is equation 5. So what is equation 5? See here, equation 5 I am writing. Rho nu. What is that? Equation 5? A21 by B21 by N1 by N2. What is that? N1 by N2, B12 by B21 minus 1. That one only, na? Equation C. A21 by B21. A21 by B21. N1 by N2 and B12 by B21. N1 by N2, B12 by B21. B12 by B21 minus 1. That is the equation. What is this equation? Earlier what is the fifth? Now it is a equation 6. It is equation 6. Okay. Now we have to solve this equation. How to solve this equation? Simply by placing the terms N1 and N2. By placing the terms N1 and N2. What are N1 and N2? Just now we discussed. N1 and N2 are nothing but atoms present in the lower energy level and higher energy level. Ante N1 is nothing but atoms present in the E1 level. N1 is nothing but atoms present. Where they present? In the E1 level. Okay. So what is N2? Number of atoms present where? Very good. Present in the E2 level. So we know that E2 is greater than E1. Okay. So we have to know how many number of atoms are present in the E1 level, means N1, how much the value of N1. Next, how much the value of N2. So how we can get the values of N1 and N2. So to understand that one, we have to use Boltzmann distribution function. Boltzmann has given how the atoms are distributed in different levels. Boltzmann, you might have heard his name. Okay, Boltzmann. Boltzmann has given the distribution of atoms in different energy levels. Atoms, how they will be distributed in different levels. See here, Boltzmann distribution. Usually, see here, Boltzmann distribution. Now, what is this? Number of atoms I am taking on x-axis. Number of atoms on x-axis. Next, this is energy on y-axis. That is on y-axis. So, see here, it is a lowest energy level. That is a lower energy level. That is E1. Next, above this, in this level, there are number of atoms are present. See how many number of atoms are present here. Example only. It is not compulsory that that E1 level should have only 6 atoms. I am giving only example representation here. So from this example, E1 is a lower energy level. E1. How many number of atoms will be there in that E1 level? So N1. Next, above this level, you will have one more level that is called E2 level. So that E2 level, how many number of atoms will be there? See here, 4 number of atoms. The number of atoms present in the E2 level is called N2. Okay, no? Next, you are having one more energy level, that is E3. That is higher energy level. Which energy level is higher energy level? E3 or E1? E3. How many number of atoms are there in E3 level? Only 2. Means, from this what you understood? E3 is greater than, E2 is greater than, and E1. Okay, E3 is the highest energy level. Next to this one. Next to lowest energy level is E1. So E1, E3 is the highest energy level. But what about the number of atoms here in E3 level? N3. What about the number of atoms in E2 level? N2. What about the number of atoms present in the E1 level? N1. Which level having more number of atoms? Either E1 is having number of atoms N1. N1 is more only now. N1 is more. How many number of atoms? 6. How many number of atoms here in N2? 4. Means N1 is greater than N2. Similarly, E3 level, how many number of atoms are there? N3. How many number here? 4. So N2 is greater than N1. From this, what you understood? Very simple. When energy levels are increases. When you are going on, when you are moving on to the higher energy levels, the number of atoms occupied into the higher energy levels will be decreases. The number will be decreases. Where you find more number of atoms? Usually in the ground state. Ground state obviously have more number of atoms. When you are going on moving to the next higher energy levels, number of atoms will be decreases. This is the Boltzmann distribution of atoms in the different energy states. That is a Boltzmann. So what about, from this only I want to continue one more thing. Population inversion means having more number of atoms. For example, it is a lower energy level. Here we are having only 3 atoms. Next, this is E2 level, E1 and E2. If you have number of atoms here N2, here N1. So when you have a condition N2 is greater than N1, then it is called population inversion. Having more number of atoms in the higher energy level than its lower energy level, then it is called population inversion. Generally, it won't happens by itself, but normal distribution of atoms will be like this. To have more number of atoms, that you need some external energy, that only called as pumping. You can't have more number of atoms in the higher energy level than its lower energy level. Usually it won't happen. To happen this condition, you have to apply some external energy. That is called pumping. Okay, pumping is a process of achieving population. Means achieving more number of atoms in the higher energy level than its lower energy level. Usually by itself it won't happen. You have to give some external energy. What usually happens by itself? This is the general distribution of atom in the different energy level. That was given by Boltzmann. Why I am explaining this one? In order to explain this one. So this one. I have to go for N1, N2. What is N? Using Boltzmann distribution function. Boltzmann distribution function. Distribution function. So what we are having, Ni is equal to N0 into exponential or e power. Exponential or e power, both are same. Exponential of minus Ei by kT. Okay, where k is a Boltzmann constant. What is it? K is a Boltzmann constant. It is a Boltzmann distribution function. What is Ni? Ni is nothing but number of atoms present in the Ei level. For example, see here. These are the different energy levels. These are the different energy levels. For example, it is E1, it is E2, it is E3, so on like this. It is Ei level. What is this? Ei level. So here number of atoms are present N1, here number of atoms present N2, here number of atoms present N3. In Ei level, how many number of atoms present? Ni number of atoms. Ni is nothing but number of atoms present in Ei level. Which level? Ei level. So Ni is nothing but what? Number of atoms present in the Ei level, Ei energy level. Next, what is N0? Number of atoms present in NO. I am writing shortcut, not NO. It is number of atoms present where? Present in ground state. ground state. Number of atoms present in ground state. Next, what is K? Boltzmann constant. What is T? Temperature, absolute temperature. So we have to use this equation in this above one. Once again I am writing what is photon density? Rho nu is equal to A21 by B21 by N1 by N2 into B12 by B21 minus 1. What is the what is the Boltzmann equation? Ni is equal to N0 into exponential of minus Ei by kT. From this equation we can write N1. What is N1 here? Means I has to be replaced with 1. I has to be replaced with 1. So N1 means number of atoms in E1 level. N0 exponential of minus E, I has to replace it with 1 by kT. Similarly, N2 is nothing but N0 exponential of minus E, I replaced with E2 by kT. Now what I need here? N1 by N2. What I need? N1 by N2. What I need? N1 by N2. Okay, so N1 by N2 means this one. N1 by N2. So N0 cancel. What I am left out here? N1 by N2. Now what I am having? Exponential of minus, see here, what I am having? Exponential of minus E1 by kT, and this numerator comes to, denominator comes to numerator. So e to the power of minus, it will become plus E2 by kT. So these are 2, e to the power of A into e to the power of B, means e to the power of A plus B, means minus E1 plus E2, exponential of minus E1 plus E2, means what I can write here? N1 by N2, what I can write here? Exponential of E2 minus E1 by kT. What about the E2 minus E1? E2 minus E1. For example, you are having two energy levels, E1 level, next E2 level. Higher energy minus lower energy. What you are having? For example, if you are having 0.2 electron volts, here you are having 1.2 electron volts. So 1.2 electron volts minus 0.2 electron volts, you will get a positive value. What you will get? Positive. Means E2 minus E1 means positive energy. Energy means what? H nu. What you are going to get? N1 by N2 is equal to e to the power of H nu by kT. Now what I am doing? I am substituting this value here. So I am substituting that N1 by N2 here. So therefore, rho nu is equal to, what is this? A21 by B21 by N1 by N2. What is N1 by N2? Exponential of what? H nu. Exponential of H nu by kT. N1 by N2. N1 by N2 is exponential of H nu by kT into what you are having? B12 by B21 minus 1. So let it be equation, but what is the previous equation that we have? 5. What is that? Rho nu 5. This equation will be 6. It is a 6. It is a rough work that I have done here. Okay, equation 6. Now, what is rho nu actually? It's very simple. Anybody from the class? What is rho nu? It is a photon density. What is photon density? So, photon density, whenever we come across the term photons means, immediately we have to recall one person. Okay, photon density, Planck's Okay, so Planck has given an equation for the photon density. According to Planck's photon density. What is the photon density? He is given one equation, rho nu is equal to 8 pi h nu cube by c cube by exponential of h nu by kt minus 1. H nu by kt minus 1. It is h nu. H nu by kt minus 1. So this is equation 7. What are equations 6 and 7? Very simple, students. Just go through that equation 6, rho nu. What is about the equation 7? See, rho nu only. Rho nu means photon density. Means equation 6 and equation 7 both are representing the equations of photon density only. Okay, both are the equations of photon density. Okay. What I am writing here? What is equation 6 and 7? Both are photon density equation. What is rho nu? What I am having? See here. What is equation 6? A21 by B21. A21 by B21 by. So instead of writing this, I am comparing here itself. Comparing equation 6 and see here, equation, this one is rho nu only, it is also equation 6. So I am comparing equation 6, this term A21 by B21 is nothing but this term. Okay, so what I am comparing equation 6 and 7. Equation 6 and 7. Both are equations of photon density. So what is there? A21 by B21. A21 by B21 is equal to what we can write here? 8 pi h nu cube by c cube. 8 pi h nu cube by c cube. Let it be equation A. That is equation A. Next, I am comparing one more thing. See here, what is the multiple of B12 by B21? Exponential 1. Okay. Similarly, exponential multiple what you are having? 1. Nothing is there means 1. Means what you can write? This term B12 by B21 is nothing but 1. Because this term and this term are same. What is the multiple of this one? B12 by B21. What about this one? 1. So what I can write? B12 by B21 is equal to 1. Okay. So from this what I can write here? B12 is equal to B21. Let it be equation B. So equation A and B are Einstein coefficient. Equations A and B are Einstein, relation between Einstein coefficient. Relation between Einstein coefficient or Einstein coefficient relations. Relation between Einstein coefficients. Einstein coefficients. Okay. So that is the topic. Okay. So that is the topic. In this, the three topics are covered. What are the first one? The question itself. What is the question? Einstein coefficients and their relations. Einstein coefficient. What are the Einstein coefficient? A21, B21 are Einstein coefficients only. What is the A21? A21 is Einstein coefficient for spontaneous emission. What is B21? It is Einstein coefficient for stimulated emission. Okay. Next, what is this one B12, B21? They are related to stimulated absorption. It is related to stimulated emission. Okay. So these are the relation between Einstein coefficient. So this is the general distribution of atoms in the different energy level. See here, there are two conclusions from this question. There are two conclusions. What is there here? Comparing, what you are comparing? Stimulated emission rate with stimulated absorption. What is the stimulated emission? Emission means downward transition, N2. Stimulated means you have to come across rho nu. Rho nu term should be there. Okay. And what is the constant? Einstein coefficient. Stimulated emission means 2,1. Emission means 2,1. B21, N2 and rho nu and the transition time delta T. I am not writing there. Next, stimulated emission with stimulated absorption. Absorption means upward transition, B21. Absorption means it depends on number of atoms, N1, and depends on photon density, rho nu. Okay, so rho nu same here. And B21 and B12, B21, this is B12. B21 and B12 both are same. Just now we derive the Einstein coefficient, relation between equation B. What is equation B? B12 by B21 is equal to 1. Means B12 is equal to B21. So that is Einstein coefficient. From this what you understood here? So these are also cancelled. Since B12 is equal to B21. So what you are left out here? N2 by N1. Okay. To have more downward transition, to have stimulated emission more, in order to have more stimulated emission, the number of atoms should be more in the higher energy level. What is N2? N2 is this one, E2 level, and it is E1 level. The number of atoms present here, that is called N2. Next, the number of atoms present here, N1. So, in order to have more downward transition, okay, we required more atoms present in the higher energy level. N2 should be greater than N1 in order to have more stimulated emission transition. Stimulated emission transition to have more, so more number of atoms should be there in the higher energy level. So that is the conclusion. N2 should be greater than N1. N2 anedi etla undalamma? N2 is greater than N1. Next, comparing stimulated emission with the spontaneous emission. Here what you are having? Stimulated emission with spontaneous. What is stimulated emission? Stimulated emission, same, N2, rho nu. What is that? B, stimulated emission, B21, N2, rho nu, okay, by spontaneous emission. Spontaneous emission means A21, N2. Rho nu term is not there. So N2, N2 gets cancelled. Means it directly proportional to rho nu. To have a more stimulated emission, what you required? More external photon density. You need more external photon density. So see here. So from this, from both the cases, what you understood here? See here, it is two levels, E1 and E2. Okay. So to have more transition, downward transition, stimulated transition, what you required? More number of atoms. You required more number of, N2 should be greater than N1. What is? N2 should be greater than N1. And what is, one more thing is required? Number of photons. Number of photons which are interacted here. Okay, that is nothing but photon density. It should be more. Okay, to have more stimulated emission, we should have more number of atoms in the excited level, and also we should have more photon density. If you are having more photon density, you will have more downward transition. If you have more number of atoms, then also you will have more downward stimulated emission transition. So these are the two conclusions from the unit. Next one is explain the construction and working of ruby laser. At the beginning of my class, I given some examples of different types of lasers. I mentioned some different types of laser. Okay, in that solid state laser. Which one? Solid state. I mentioned two examples, in which one is ruby laser, another one is ND-YAG laser. These are the two solid state lasers. In our topic, this question also more frequently asked question. Actually, how many lasers that we are having? Ruby laser, helium neon laser, semiconductor laser, ND-YAG laser. Okay, these are the different lasers that we are. So from these lasers, it compulsory we are going to get one question. So most frequently asked this question. This question asked more frequently as it compared with the other questions. How many lasers that we are having? Ruby laser, helium neon laser, semiconductor laser. Okay. Next, ND-YAG laser. So out of these lasers, which question asked more frequently? Ruby laser. What is ruby laser? Is a solid state laser. What is ruby laser? Is a solid state laser. It is a 3-level laser. Okay. See here, ruby laser. So first laser to be operated, first active laser operated. Okay. So by Maimon, in the Th Maimon in the year of 1960. What is the year? In the year of 1960, Th Maimon successfully demonstrated first active laser. I repeat, in the year of 1960, Th Maimon, he is a physicist who first demonstrated the first active laser. What is? He is the one who demonstrated the first active laser. In which year? 1960. In which year? 1960. First active laser. It is a solid state laser. But it is solid state laser. So it is a solid state laser, as I told you. Ruby laser is a 3-level solid state laser. 3-level. What is the 3-level lasers that I am going to? What you know about the 3 levels? For example, it is the lower energy level. It is the excited level. There will be one more level we are having, that is E2 level. So ground state, excited state, meta-stable state. What is this? Meta, you have to come jointly you have to write. Meta stable state. This is metastables. 3 levels. How many levels that ruby laser will have? 3 levels only. Okay. So it is a lower level, means ground state, excited state. In between lower level and higher energy level, there will be a in between one level, that is called metastable state. The name itself is saying that it is staying metastable, means somewhat stable compared to excited state. As I told you, whatever the atoms which are present here, when they excited to higher energy level, they will stay this much amount of time only, 10 to the power of minus 8 seconds only. Means very less amount of time the atoms will stay in the excited level. So the lifetime of the atoms in the excited level is very less. So they will come down. For the disturbance. So ruby laser is a first active laser demonstrated by Th Maimon in the year of 1960. Okay, 3-level laser. So it is ruby laser optical pumping technique. Which kind of pumping? There are different pumping. What is pumping? Just now I discussed. Previous topic. In Einstein coefficient pumping, we have to excite the atoms from lower energy level to higher energy level by providing some external energy. Then what happened? These atoms will reach to the higher energy level. Why we are applying some external energy? Because to have more number of atoms in the higher energy level. To have more number of atoms in the higher energy level, we are using that one. Okay, na? So that is called pumping, nothing but process. What is pumping? Pumping is a process of achieving population inversion. What is population inversion? Very simple. Having more number of atoms in the higher energy level than its lower energy level. That is called population inversion. How you will get this population inversion? Not just like that. You have to apply some external energy. So that energy that we are using, that called pumping source. The method that we are doing called pumping mechanism. The process is called population inversion. Achieving a population inversion is called pumping. The process of achieving population inversion is called pumping. So to have more population, we have to use some external energy. So which kind of energy that we are using? Optical pumping mechanism that we are using in ruby laser. In order to get more number of atoms in the higher energy level, which kind of pumping mechanism that we are using? Optical pumping technique is used. Means optical pumping means simple, light. Which kind of energy you are using? Optical means light form of energy that we are using, okay, to supply energy to the laser medium. So here we need some elements, chromium ions, Cr plus 3 ions are the active centers here. So this is a brief note about the ruby laser. First, what is a ruby laser? It is a first active laser demonstrated by Maimon in the year of 1960. It is a first active laser. So what it is? It is a solid state laser. Which level laser it is? 3 level or 4 level? 2 types of levels we are having. 3 level laser. What is 3 level? Lower energy level, higher energy level. In between these 2 levels, one more level is called metastable state. Okay, so that is one. Which kind of pumping mechanism that we are using? Optical pumping. What is pumping? Why pumping mechanism is needed? So to get the lasing action, we need population inversion. Without population inversion, lasing action can't be done. Once we achieve the population inversion, next followed with stimulated emission. First, what we have to achieve? Population inversion followed with stimulated emission. Then what we are going to get? Lasing action is there. So which kind of pumping? Optical pumping mechanism is it. So what are the materials, what are the ions that we are using, active centers? Chromium plus 3 ions. See here. Okay. Construction. How the ruby ray. See here, the ruby laser, the ruby crystal is a form of cylindrical. Which shape it is having? Cylindrical. Okay. So usually having the length 2 centimeter to 30 centimeter length, and the diameter is 0.5 centimeter to 2 centimeter. So see here the diagram. It is a ruby laser. Which kind of form it is? Which kind of form it is? It is a cylinder. And what is the length? Length of this one is 2 to 30 centimeter. How much the length it is having? 2 to centimeter. What is the diameter? This is the diameter. So what is the diameter? 0.5 to 2 centimeter. So first construction. Ruby laser, I told you, it is a solid state. Means cylindrical shape. Solid means rigid body, strong body, in which atoms and molecules are very closely packed. Okay, so that is solid, you know, solid state laser. What is the shape of this ruby rod? It is a cylindrical in shape. Okay, it is a cylindrical. So typical length is how much? 2 to 30 centimeter. Typical diameter is 0.5 to 2 centimeters. See here. Now what we are doing in the ruby rod? Actually ruby rod is nothing but Al2O3. What is ruby rod? Al2O3. That ruby rod is doped with Cr2O3 oxide, means chromium oxide. When we are adding this Cr2O3 in the melt form, okay, melted form, so Al2O3 is doped with Cr2O3. So what happened? How much we are doping Cr2O3? For example, we are having, it is a ruby rod. So for example, if it is having 1000 grams, what is this? 1000 gram. What is 1% of 1000 grams? 10. What is the 1% of 1000 grams? 10 grams. Okay. So similarly, what we are doing here? 10 grams. We are not doping only 1%. Whatever the ruby rod is there, from that weight, whatever the weight it is doing, we giving, from that weight 0.05 percentage weight. How much? This much of percentage of weight of the ruby rod. See here, it is a Al2O3 ruby rod. That ruby rod is doped with, what it is? Doped with Cr2O3 ions. It is doped with Cr2O3 ions. What happened to this ruby rod? That ruby rod get into the color. Which color? What you are seeing here? Which color you are seeing here? Very good, pink color. So Al2O3 is doped with Cr2O3. How much you are doping? Only 0.05% of weight of the ruby rod. Then the color of the ruby rod is pink color. So now the two ends of the ruby rod are placed with two mirrors. See here, this is ruby rod. The two ends are finely polished. And after that we are placing two mirrors. One end mirror M1 fully reflector. The another one is there. The another one you are having one more mirror M2. It is what? M2 is partial reflector. What is fully reflector? It is 100% silver coated. Which coated? Silver coated. So this is perfect fully reflector. It is partial reflector, means less than 100% silver coated. Silver coated. So two mirrors that we are having. One is partially coated, another one is fully coated. So now we need a pumping source, pumping mechanism. Means to excite. To whom we have to excite here? Chromium ions. To whom we have to excite? Chromium ions. Why chromium ions are the active centers? What it means? Active centers means they are the responsible for the lasing action. The ions which are responsible for the lasing actions are called active centers. Okay? So what we are doing? We need some external light energy. What we need? Some external light energy to excite the atoms from lower energy level to higher energy level. Means we have to get population inversion. So which kind of energy? Optical pumping technique was used. I wrote some things. You already seen. Which kind of technique we are use? Optical pumping mechanism. See here, optical pumping mechanism technique was used. So Al2O3 is doped with Cr2O3 ions, then it will become pink color. One end of this one you are having fully reflector. The other one you will have partial reflector. Okay. Now we are using helical flash lamp. What it is? Helical flash lamp, which is filled with which gas? Xenon gas. Okay, so a helical flash lamp which is filled with xenon gas, when it is given some power supply, that flash lamp will generate greenish blue color. Which kind of pumping mechanism we are using? Optical pumping. How that light we are going to generate? By using a helical flash lamp. That flash lamp is having what it is enclosed with? Xenon gas. It is enclosed with xenon gas. See here, this is a construction. So in between, what is this one? What is this one? Ruby rod. What is this? Ruby rod. Okay, now? This is ruby rod. This ruby rod, one end what you are having? Fully reflecting mirror. What you are having? Fully reflecting. This is fully reflecting mirror. This one. Fully reflector. Means 100% silver coated. The other one is partial reflector. What you are having? Partial reflector. It is a fully reflecting one. It is partially reflecting mirror. And where it is enclosed in a, what you are having? Ruby rod, where it is enclosed? In a discharge tube. What is this? It is a discharge flash tube. Okay. So over that tube, what you are having? Helically shaped. What is this? Helical shaped. Helical shaped xenon flash lamp. What it is? Helical shaped xenon flash lamp is. So what it is having? Inside xenon gas. So that xenon gas is connected to power supply. Okay. So whenever you are giving some external photon, means light energy, means xenon flash lamp is generated some light. Xenon flash lamp will generate some light. Which kind of light it is? Greenish blue color light. So whenever the laser emits from the device, it generates high amount of temperature. Whenever laser emission takes place from the device, means from the device, what happened? It will generate high amount of temperature. So when it is generating high amount of, it decreases the efficiency of the laser output. That means the output, the laser that we are getting, its efficiency will be decreased. Who is decreasing the efficiency of laser? the temperature generated during the emission of laser. Okay, so in order to in order to control the efficiency, in order to not to reduce the efficiency, what we are using? We are using cooling techniques, liquid nitrogens that we are using in order to balance the temperature of the quartz tube, the tube that is enclosed with the ruby rod. So that is Al2. Listen here. First, we need a ruby rod. This is a ruby rod. What is ruby rod? Al2O3, which is doped with Cr2O3. How much? 0.05 means Cr3 ions. How much? 0.05% weight of the ruby rod. Then what is the color of ruby rod? It will become pink. It is having two ends. One end what you are having? Fully reflector. Another one partial reflector. Where you place this ruby rod now? You place this ruby rod in quartz tube. Over the quartz tube, what you are having? An arrangement of helical flash lamp. What you are having? A helical flash lamp. That helical flash lamp is connected to power supply. Okay, what you are having? Power supply. So when the power supply, it is a construction. How the working is there? See here. High temperature is produced during the operation of the laser. The rod is surrounded with what? Liquid nitrogen to cool the apparatus. I said just now. So when laser emission takes place, what happened? A high amount of temperature will be produced. In order to cool the temperature, what techniques that we are using here? Which technique we are using? Liquid nitrogen is used here in order to lower the temperature, control the temperature. See here, working and energy level diagram. ELD diagram also we are calling. What it is? Working and energy level diagram. So how many level? It is a 3-level laser. Just now we discussed. Ruby laser is a 3-level laser. It is a solid state laser. Just now we said 3 level. What is E1, E2 and E3 levels? E1, E2 is what? E1 is the lower energy level, E2 and E3, E4. What is E1 and E2? See here. See, it is a ground state. What is this? Ground state. So ground state, what you are having? Atoms. Okay. So what you are providing? A photon. How much of wavelength? Greenish blue color. Greenish blue color. Green color is having, what is VIBGR? What is VIBGR? From left to right, lambda will be increases. Left to right, lambda wavelength. Means red color is having more wavelength than the violet color. Means wavelength is more, means energy is less. Means which color is having more energy? Green color and red color. I am having bluish green. Blue color I am having, and I am having one more color, green color. So this blue color having more energy. Energy of the blue color is more than the energy of green color. So BE is greater than GE. Energy of this one. See here. See here. Once again I will repeat. See here. It is a ground state. In ground state, what you are seeing here? Very good. Atoms. Okay. Now we have to excite these atoms. To excite this atom, we need pumping mechanism. So what kind of light you are getting? Bluish green color. So for example, see here, it is a 4000 angstrom light. It is a bluish color. Okay. What happened when this atom absorbs this photon? When this atom absorbs this photon of wavelength, what happened? It won't stay here. It will excite to which one? This level is called E4 level. Which level it is exciting? E4. Which level it is called? Blue color absorption band. Atom is excited to blue color absorption band. Similarly, bluish green color I said. One blue color is. Next green color. So atom is excited. See one more side. When photon is falls on it, what happened to the atom? This atom is excited to blue color band. Similarly, come to this atom. This atom is interacted with which wavelength? 5600 angstrom. Okay. Bluish green color. It is what? Green color wavelength. What happened when the photon of this wavelength falls on this atom present in the ground state? This atom will excite it. So which photon having more wavelength? Green color. Means it is having lesser energy. Means it will locate at the lowest energy level. Means green color absorption band. Now we are having two excited levels. These two are the excited states. excited states of chromium plus 3 ions. They are the excited states of the chromium plus 3 ions. They are the excited state. Once the atoms, next what happened, this atom will go from this level to this level by absorbing this photon, 5600 angstrom. As I said earlier, are these atoms will stay in the higher energy level, means excited level there itself permanently? No. Why? Because their lifetime is very less. They want to get stability. Where they will get stability? In the ground state. Obviously, the atoms which are excited always tries to get into the ground state. Okay, so the atom won't stay in the higher energy level. Very less amount of time. What is the lifetime here in the excited level? 10 to the power of minus 8 seconds. Here also 10 to the power of minus 8 seconds in excited level. Now the de-excited atoms has to come down. But we have to get lasing action. We have to get population inversion. For that population inversion, we create a metastable state. One more level. 3 level what you are having? Excited level, ground level. In between these 2 levels, you are having one more level, metastable state. What is a metastable state? It is a state where atoms can stay some more extra time. Means they can stay more time in the metastable state, where it is not possible in the excited state. Atoms can't stay much higher time in the excited state. Where this can be happen, means in metastable state you can allow the atoms to stay for some more time. When you are, so transition of the atoms from blue color band to and green color band to metastable state. Once you achieve the population inversion, once chromium ions enters here, so you will going to get chromium ions here. What you are getting? These are the chromium ions. These are coming from not only from the blue color band but also green color absorption band. Now the transition of chromium ions takes place into the metastable state. You achieve the more number of atoms here. What it is? More number. That is called E1 and it is E2. Number of atoms present in E2 is N2. Number of atoms present in the ground state is N1. So when N2 is greater than N1, that is called population inversion. When you are having more number of atoms N2 than the ground state, you are having, it is a ground state. Here for example, you are having less number of atoms. N1 is less, ground state. N2 is more. You are having N2 is more than the N1. You achieve the population inversion. Once we achieve the population inversion, what happened? Stimulated emission process takes place. What is stimulated emission? Just now we discussed. So when the stimulated emission process, what results? See, lasing action. See here, when the atoms are coming from this level to this level, non-radiative emission takes place. Means no laser emission takes place. When atoms coming from blue color band to and green color band into the metastable state, so there won't be any laser emission. Non-radiative emission takes place. Okay, now that non-radiative emission is not a laser. Once we achieve the population inversion, the atoms will, it is a ground state. So atom will come down to the ground state. See here. I repeat one more time that animation. See here. There is a ground state having atoms. Now, what is the color that xenon flash lamp is generating? Greenish blue color. Means green color having more energy, blue color having lesser energy. The chromium ion which absorbs the blue color will excite to more higher energy level. The chromium ion which absorbs the blue color, which will go to the higher energy, WebGR. And next see here. So this is the photon of this wavelength which falls on it. It is excited and it is enters into the E4 level, that is blue color absorption band. So this atom is moving like this. Next this atom is there. So this is blue color wavelength light. Next we are green color wavelength light that is falling on the atom. It is excited to green color. It is excited to green color band. These two atoms won't stay in the excited level. They have to come down to the metastable state. We are having an arrangement called E2 level, that is metastable state. So the transition of atom takes place to metastable state. So these atoms are going. So while the atoms coming from these excited states to metastable state, they are releasing the energy, that energy non-radiative energy. What is that? It is a non-radiative transition. Non-radiative transition. Once the atom reaches to the metastable state, you will have more number of atoms. So you achieve the population inversion. Once achieving the population inversion, what happened? Lasing action takes place. Means these atoms will come down to the ground state. So we will get two kinds of wavelengths, 6927 angstrom and 6943 angstrom. These are the two wavelength laser beams emitted during the transition of atoms from metastable state to ground state. Metastable state to ground state. So when atoms are coming, we are getting two different wavelength lasers. One is 6927, another one is 6943 angstroms. So two wavelengths, in which this one 6943 angstrom is called ruby laser. What is that? Ruby laser. What is the wavelength of ruby laser? In question, choose the correct answer. They may ask. What is the ruby laser wavelength? 6943 angstrom. What is the color of ruby laser? What is the color of ruby laser? Red color. What is the color of ruby laser? That is red. What is the color of ruby rod? Pink color. When Al2O3 is doped, Al2O3 is doped, Cr2 plus O3, how much? 0.05 percentage. Okay, then it will convert into pink color. That will be pink color. Ruby rod color is pink, but ruby laser color, red color. That you have to remember. Okay, what is the color of ruby laser? Red. What is the color of ruby rod? Means solid material. We kept that rod in the tube, quartz tube. Okay, what is that color? It get into pink color. So this is the output of the ruby laser. What you are understanding here, by seeing the diagram, one can easily understood that we are having x-axis what? Time. Y-axis is output power, power output. Y-axis what I am having? Power output. X-axis time. So what happened as time increases, the power is, there is not uniformity. There is not, it is not maintaining. Power is not constant. Power is not constant. And power is not increasing. There is a fluctuation in the power output. Power is sometime maximum, sometime minimum. Sometime maximum, sometime minimum. Means power output means the laser emitted, the ruby laser which is emitted is not continuous form. The emitted laser, here the laser is emitted, na? The laser is emitted, na? This emitted laser is not continuous form. It is not continuous form. The laser is not continuous. Okay, there is a laser coming and the laser is diminished, means coming and going. That is not continuous form. It is not continuous form. Laser is not continuous. Means how it is? It is a pulsed form. Ruby laser, the output is pulsed form laser. Which one? Pulsed form of laser. Pulsed form of laser. So that is ruby laser. What is ruby laser? It is a solid state laser. And which level laser it is? 3-level laser. Okay, na? Which material we are using here? Al2O3. Okay. So that Al2O3 is doped with what? Cr2O3. Okay. How much we are doping Cr2O3? 0.05%. Then what will be the color of the ruby rod? Pink color. Now this ruby rod is placed in a quartz tube. So which kind of pumping technique we are using? Optical pumping. Optical means light pumping. So to get the light, what kind of tube that we are using? Helical shaped tube, flash lamp we are using. So helical shaped flash lamp is enclosed with what? Which gas? Xenon gas. When that helical shaped tube is filled with xenon gas connected to a power supply, the tube will generate light. Which light it is generating? Greenish blue color light. Means it is having green color light and also having blue color light. Okay. So what happened to the, who is the active centers in the ruby laser? Chromium plus 3 ions. What happened to the chromium plus 3 ions? They will excite to different energy levels. Okay. So after that we discuss how the lasing action takes place. The chromium ions won't stay in the higher energy level for a longer time. We have to allow them to stay into the metastable state. Okay. So once we make them to stay in the metastable state, we will achieve the population inversion. Once the population inversion sorry, achieved, we will get a stimulated emission. For the stimulated emission, lasing action we are going to get. How many lasers that we are getting? 2 wavelengths, 6927, 6943 angstrom. 6943 angstrom is the wavelength of a ruby laser. What is the color of ruby laser? Red color. What is the color of ruby rod? Pink color. Okay. So hope you understood. So what is the output of ruby laser? Ruby laser output. Is it a continuous waveform? Continuous waveform or pulsed form? Pulsed means on and off. Pulsed means what? It is coming and leaving. Pulse coming and leaving. Not continuously emitting. Why continuous? Why we are not getting continuous waveform? See here. Why we are not getting continuous waveform? Why we are not getting? Why we are not getting continuous waveform in the case of ruby laser? Why we are not getting continuous wave? See here, very simple. As we know that ruby laser is a 3-level laser. It is the excited level, means E3. So forget about the green color and blue color. Both they are excited levels only. E3, I said we are having green color absorption band and blue color. They are excited level. They are excited state. Excited states. Next we have a ground state, E1. What is this? It is a ground state. It is a ground state. Okay. In between there is a one more state called metastable state. What it is? Metastable state. Okay. So when we are giving some external energy, means pumping. When we are using a pumping technique. Which kind of pumping technique? Optical pumping technique we are using. Means light. Means we are giving some photons. Photon energy. We are giving some photon energy to this atom. What happened? These atoms will excite to higher energy level. They will go and reach to the higher energy level. Excited states. They will reach. And they won't stay in the higher energy level. They will come down. So, but we need a population inversion. So for that what we use? A metastable state. So we allowed these atoms into the metastable state. Okay. Now you are having atoms in the metastable state. For example, this many number of atoms we are having. Now it is a ground state. What is this? Ground state. When atoms are coming to, how many number of atoms are there? 1, 2, 3, 7 number of atoms here. That is N2 number of. Here N1 is no number of atom. N1 is 0. No atom is present in the ground state. Now few atoms are coming down here. Now you becomes 2 and here you becomes 7 means here 5. Now 5 and now you becomes 2. 2 more atoms are de-excited. What happened? Now you become here 3 and you become 4. Means lower energy level having more number of atoms. Lower energy is having more number of atoms. Higher energy is having only 3 atoms. Higher energy is having only 3 atoms. Lower energy is having more atoms. Means you lost the condition called population inversion. Means every time atoms are de-exciting from metastable state to ground state and losing their number, more number, means losing the population inversion condition. Whenever it loses the population inversion condition, what happened? Laser emission stops. So laser emission takes place and stops. When laser emission takes place? Whenever you are pumping and causing more number of atoms in the excited level, then laser emission takes place. Whenever the atoms are coming down, you are losing the population inversion, laser emission stops. Means laser emission is not continuously taking place. That is the reason ruby laser is not continuous form. It is a pulsed form. Okay. So I hope you understood. So thank you very much for your attention and thank you very much for your time. So good night all of you.